Hello students, welcome back. And today I will present the motional EMF of chapter number 7, and this is the lecture number 2. So what is EMF? First of all, we should know about motional EMF. So the motional EMF, the EMF is generated due to the motion of a wire or rod, is known as motional EMF. So how we can induce the EMF by motion, we will consider an example. Consider an example. Consider we have a magnetic field. This is the symbol of magnetic field, which indicates that this magnetic field is inside this port. So visualize this, some magnetic field lines coming from this side, and this is into the this board. And whenever the magnetic field coming towards us, if the magnetic field coming from the board, then usually this can be represented by dot. So remember this point. This is actually the representation. And here we have a wire, and here there is some resistance or some bulb, some anything, and the height of this loop is h, and this is the area which is inside this magnetic field. So if I write down the value, let's suppose this corner is A, this is B, this is C, and this is D. So A, B, C, D, this is inside this magnetic field. Now, if someone pull this wire to this direction, if someone pull this wire with some force in this direction with some velocity V, then a current is generated in this loop. So this is why this will happen. If we move a coil or a rod or anything in a magnetic field, and it can induce a current in the loop. So we are looking for the cause of this current is generated in this loop. So this may be anything like resistance, maybe bulb, or any other electronic device. Now I want to write down something. Here, this H, this V, and this magnetic field means this H means this length, and V or B perpendicular to each other. How we can visualize this? Here, if we consider the magnetic field in this direction, the velocity of the coil in this direction, and the length of this wire, this is the length of this wire. So this is actually the magnetic field, the velocity, and this length. Okay. So I have write down something about this diagram. If the entire loop is pulled with a velocity v, this entire loop is pulled with some velocity v, the charges in segment AB, only the charges in segment AB experiences a magnetic force whose vertical component QVB drives the current around the loop, and the EMF must be written like this: magnetic force, the magnetic force per unit charge, and the length. Here it should be noted that in this case the segment AD and BC could not contribute, because here the force is perpendicular to the length, here is also perpendicular, but here the force is a line. So this AD and BC will contribute nothing in this, but only AB will contribute, and here the charges inside this AB experiences some force, and this may be represented like QVB. This is the magnetic force. Magnetic force is equal to Q into V cross B. So if angle is 0, then we can have sine 0 is equal to 1. So QVB, the magnetic force is equal to QV and B. Okay. Now, this EMF can be written like this. What is F magnetic force now? This is actually the force per unit charge. This MF magnetic force, this is actually the force per unit charge. So the magnetic force we have QVB divided by this, then Q will be cancelled out, and we can get F magnetic force, the force per unit charge is equal to VB. So we can put the value of this in this equation. So EMF must be equal to VB dot dl. And further, the angle between this is equal to VB dl. If we remove the dot product, then we can get like this. And here VB we can consider like this, and dl, what is the total length here? The total length is here AB, and AB is equal to h. So this is equal to VBH. So finally, this force, electromotive force, EMF, this is equal to this. So if I write down this VBH, and I label this with equation 1. As we establish EMF in equation number first, but we can study more about this EMF, because the magnetic force do not any work. So the question is, who is responsible to do this work? Because the magnetic force do not any work. So who is responsible when somebody pull this loop to the right? Then this person is responsible for the work. So I have written this here. The work done is due to the person who's pulling the loop. The person is responsible for doing this work. The free electron in segment AB have vertical velocity here. If the person pull this loop to the right with velocity v, the free electron in this segment AB, I will write down the free electron in segment AB have vertical velocity. And say this is u. If this is moving in this direction, then the electron have some velocity in this vertical direction, and we have considered this, let's say this velocity is u. Then here there are some technical things that we have to study, because let some complications you will see here, but I want to clarify all these things, because I have the velocity of the free electron that I in the vertical direction, this is u. So if I write down this, the velocity of the electron which is in this direction, and we also know that the velocity of the loop which is in this direction, so if I add this is the velocity of the loop, then actually the actual motion of the body of the electrons will be in this direction. It will move and the particle will move in this direction. So this will be, let's say this is equal to W. This will be the actual, if I write down like this W, this is the particle is actually moving in the direction of the resultant. This is something like a resultant vector. This is a resultant vector W. Now, what will be the magnetic force here? The magnetic force will be perpendicular. So if I write down the magnetic force, this is actually perpendicular. This is F magnetic force is perpendicular to V. This is actually perpendicular to V. This is that, actually this is a two-dimensional board, so actually this is perpendicular to V. And here it makes an angle of theta. We can also represent, if I remove this, okay. So here, this is the pull. This is the F pull. When a person pull this with a force, F pull, so then this will be in this direction, and if I write the component, so this is actually the component of magnetic component UB, and this is actually the component VB. This is the component of this, and this is the component of this. the force per unit charge, and the force per unit charge in this direction, the force per unit charge in this direction. So here it is clear that the person pulling the wire must exert a force per unit charge. The person, I will write down here, the person pulling the wire and exert a force per unit charge. So if you look to this diagram, this is F pull in this direction, and here this is the magnetic force, the component of the magnetic force in this direction. So the person pulling the wire, then it exert a force per unit charge. So we can say that this F pull, this is equal to UB, because this is equal. This is in that direction and this is in this direction, so these are equal. So this is the equation that I have derived. Now the work done per unit charge, I have to calculate the work done per unit charge. Let this F pull, this is equal to UP, and I will write down this is equation 2, and the remaining things I want to remove. Now the work done, per unit charge is, how we can write down, this is the F pull dot DL. This is actually the work done per unit charge, and if I write down like this, because this is a dot product, and the dot product we can write down, this is equal to F pull DL cos of theta. So this is important point, because what is the angle between F pull and DL? So this is important, and I think in the graphic book this point is not clear, but let's see what is the angle between F pull and DL. Okay, this is the work done per unit charge, and this is equal to F pull dot DL, which is equal to F pull DL cos of theta. So what is the angle between this height? Actually we will consider this height W. This is, we should consider like this is the actual height of the particle. So this is the actual length AB, but this is the actual when it is moving in this direction, the rod. So this will be the actual distance. So DL actually this one. And what is the angle between this and this? F pull and this DL. What is the angle between this? So the total angle, if you know, the total angle is 90, and this is theta. So we should subtract angle theta from 90. So we will get this angle. And here I can write like this. 90 minus theta. So what is F full? We have already calculated. This is F full is equal to UB and DL. When this is the identity, if we open this identity, we can get sine of theta. You should do this by yourself because this is not so big problem. Now, what is DL? So this is important, how we can calculate this DL. So DL can be calculated using this angle from this triangle. From this triangle, this is actual length and this is the when it is moving. So from this triangle, cos theta is actually the base divided by hypotenuse. So the base is the length, actually the length, this is the length d, this is the length. I have to clear this point. This is the length, yes, this is the length of this segment, and we have represented this by h and divided by this is actually this, if I denote this by W. So this W length will be equal to h divided by cosine of theta. And this W, let's suppose this is actually DL. This is DL. So DL is actually h divided by cos theta. So here we put UB and DL that we have calculated, h divided by cos theta and sin theta. And finally, how we can write down this formula. So UB can be came out UB, and I can write down UB and h, all these are constants, so this is equal to tangent of theta. So what is tangent theta? What is tangent theta in this diagram? So tangent theta is equal to base divided by height, base perpendicular divided by base. I think this is perpendicular divided by base, this is perpendicular, this is base, so v divided by u. So here ub h and this is v u, so this u and this u cancel out, and finally we can get the same VBH, the same work done, the same EMF that we have already calculated in equation number 1. So EMF is equal to VBH, and we consider this kind of things, and by pulling by considering when a person is pulling the loop, and we have derived the same result as we have derived earlier.